Good morning, students. So today we're going to start with a new chapter called Conics. This is the first part of Conics. Let us see the definition of conics. So there are two definitions of conics. The first one, let us see the sections obtained by the intersection of a right circular cone by a plane in different positions relative to the axis of the cone are called conics. Let us take a right circular cone. This is a right circular cone, and the top point sorry. So let us take a right circular cone, and the top point is called vertex or apex. This vertical line passing through the apex vertically is called the axis of the conic. And these lines are called the generators. Then we have one generator on this side, one generator on the other side. The vertical length is called the altitude, and let us, for time being, understand this much. Let us go let us understand these definitions properly. Let us assume that there is a right circular cone. Just assume an ice cream cone, inverted ice cream cone. Your inverted ice cream cone is nothing but a right circular cone. Okay. Now, for example, take a blade. Take your ice cream and take one blade like this. Say this is a blade and this is the ice cream cone. And you take your blade and cut the ice cream cone in such a manner that it's parallel to the base. Okay. Then the sections which you will get is called a circle. That means how you are cutting the circular cone exactly parallel to the base. When you are cutting the cone exactly parallel to the base like this is the base and this is a cutting plane. That's called a cutting plane. When the base and the cutting plane are exactly parallel, then the sections which the remaining section you get, that is your circle. Then if you are cutting the right circular cone in an angle and it is cutting both the generators, the one generator, the second generator, and this is your cutting plane. Now if your cutting plane is inclined to the base or to the axis and it is cutting both the generators, then the section that you get is your ellipse. This is your ellipse. Then comes a parabola. Now when you're cutting the plane in such a manner that it is parallel to one of the generators, this is one generator. Let us say we're cutting it up parallel to the generator. Then the sections you will obtain is called a parabola. In this manner you get a parabola. And then the last one, hyperbola. If you are cutting your ice cream cone in such a manner that it is perpendicular or it is parallel to the axis, of the cone, and then the section what you will get is your hyperbola. So what I suggest you take 4 ice creams and you cut with your blade in this manner and try this experiment at home. Let us go to the next one. So the same thing what we have understood is I have written in words. When the section plane or the cutting plane is inclined to the axis and cuts all the generators on one side of the apex, the section is an ellipse. Parabola, when the section plane is inclined to the axis and is parallel to one of the generators, the section is a parabola. Then when the section plane cuts the cone on one side of the axis, the section is a hyperbola. Let us see the definition of eccentricity. Eccentricity, we said it is the ratio of the distance of the point from the focus to the distance of the point from the directrix. We'll see this in a while in terms of what is focus, what is directrix. For time being, you understand. Okay, let us go to that first. Let us go to that conic. What is conic? One more definition we are getting here. It is defined as a locus of a point moving in such a plane such that the ratio of its distance from a fixed point and a fixed straight line is always constant. That means the fixed point is your So how you are getting this ellipse? You are getting this ellipse when we are plotting the locus of the points and we are joining all the points together. Then the final diagram by joining all the locus points is known as an ellipse. But how will you get the ellipse? When the ratio of the distance from a fixed point. Let us say there is a fixed point here, say P. Okay, so the ratio of a distance of P. Okay, the ratio of distance from a fixed point means focus, and a fixed straight line. What is a fixed straight line? This is a directrix. It's always constant. Let us see M. According to this definition, according to the definition, PF by PM should always be constant. That is, if that is the case, then we can say that is a conic. For example, you take any point here, whether the point is located here or located here. What you have to do, if you want to define a conic, take any point P and you connect the point with the focus one time and connect the point P with the directrix one time, and the ratio PF by PM, if it is constant, then we say it is a conic. Alright, and let us say a definition of eccentricity. Distance of the point from the focus, same thing, you take any point here P, distance of the point P from the focus, okay, divided by the distance of the point from the directrix. And that constant, what you have learned, that constant is your eccentricity. Okay. Now let us go back to the previous definition. We have understood what is eccentricity. Now if that point, say, now that point, if it is that, if you take a point here, this is the vertex. If this is an ellipse, then this is directrix. Directrix will be there on both sides of the ellipse. Then the ellipse where this is the major axis, this is the major axis, this is the minor axis, and the ellipse where it touches the major axis, that particular point. When the ellipse touches the major, that particular point is vertex. On both sides you will get vertex. Then there will be fixed point on both sides, on the both sides of the minor axis. Focus here, focus here. And this focus is always constant. It's called a fixed point. This focus is not changing. Okay, so we are getting vertex both sides, focus both sides, directrix both sides. Now the point P that which we are discussing, if I take any point P, it can be point P here also, here also, here also. Vertex is also a point P. So according to the definition, this point P, distance of any point from a fixed point, between PF, distance of the point from the focus, that means PF, or in this case P and V are same, so I can say VF. VF is same as F, so VE is equal to VF, distance of any point from the fixed point to the distance of the same point from the directrix, that means divided by C is constant, and that constant term is known as your eccentricity. Alright, now come back to this one. When this is value of eccentricity, when you calculate from the diagram, if it is less than 1, we say it is an ellipse. So in this case, you see the value of E is 0.5. 0.5 is obviously less than 1, so we can say it is an ellipse. Okay, then if E is equal to 1, after you calculate from the diagram, after you find E, if it becomes equal to 1, then we say it is a parabola. And if E is greater than 1, for example, E is equal to 5 or equal to 4 by 3 or equal to 5 by 2, then we say it's a hyperbola. Alright, now let's say an example. For example, ellipse. This is an ellipse. So Let us take any point, fixed point P. P is same as V, so E is equal to of the point from the fixed point. That means PF by CP. PF is same as PF, like this, FB, and CP is same as CP is same as CB. So we get this value, and if you do one calculation, you will find that it is always less than 1. Either you will get it as E is equal to 2 by 3 or is equal to 1 by 2, always to be less than 1, and if it is less than 1, we say is ellipse, and ellipse will look like this. Then the next one, parabola. Here also, if you do one numerical, you'll see that this value will be almost is equal. It must always just lie somewhere in the between, then only it will come 1. That means this point P, PF, PF and CB should be equivalent, then only you will get this 1, and if it is equal to 1, then the diagram what you will get is your parabola. The last one, hyperbola. Hyperbola, FB is more, that means your this graph, sorry, it will lie somewhere here. Then you see that PF is more. If PF is more, then if PF is more than CB, then you will say it is a hyperbola. Alright, so let's stop here now. Thank you.